if I can just find my pointer again. All right. Hi, I'm Bobby Rullo. I work at CoreOS on Tectonic, which is our commercially supported, out-of-the-box, Kubernetes-based orchestration solution. And one of the components there is DEX, which is our open source standards-based identity provider and authentication solution, which we've just recently open sourced. So I'm going to be talking a little introduction to what DEX is all about today. So the first question you might ask yourself is, why do we even need something like DEX? There's already many, many ways of handling identity and authentication in your applications. I mean, you could get an OAuth 2 client, make your users log in with Google, GitHub, Facebook, or any of these things. There's platform-specific authentication solutions that work really well in things like Django or Rails or whatever. There's a lot of commercial offerings that'll do this stuff for you. And if you on the open source side, if you want something really complete, there's Shibboleth, which does literally everything under the sun. But necessity is the mother of invention. And about a year ago, there was a point where just kind of all the projects that were in our pipeline needed some sort of way of handling identity and logging users in, right? So we had the Tectonic.com, which we were working on, and that's where CoreOS hosts its commercial offerings. That's where you can purchase Tectonic and manage your account and all that stuff. Then Tectonic, within Tectonic, which is this hosted or Kubernetes package here, there is this Tectonic console, which is a web app for managing your Kubernetes cluster. And clearly, you don't want just anyone getting on your compute cluster and doing whatever they want. So that needed an authentication solution. And then there's the Kubernetes API itself, which, again, that's a REST-based API, and that needs some sort of authentication because Kubernetes out of the box, leaves that for you to decide how you authenticate. And then there's Quay Enterprise Registry. Quay is part of the CoreOS family, and they have a container registry. And the Enterprise Registry is the premium on-premises version. And we wanted to give people different ways of providing identity there as well. So all these things were kind of driving, we're in our thoughts and driving our decision-making process. And we really didn't want to have a dozen different solutions. So, we came up with a bunch of requirements, and they were more or less these here. So we wanted to allow users to choose how they log in, and that was especially important for Tectonic.com. When you're trying to get customers and users, you want as little friction as possible when you're signing up new people. Some people just want to get in there real quick and just, they don't want to think of a new username or password or anything, so it's nice that they can just go, use their existing Gmail account if they have that, or other Google-based email. And some people don't want to tie it at all to that. They don't want this thing touching their Google account, so they can use a different email address and just sign up with a username and password. And that's so we wanted to handle both sorts of situations in that case. The other thing is we wanted to be able to, in certain cases, it's really important to own identity. And what I mean by that is, you're the one who's in control of what accounts can exist, revoking access, and having a tight control over who can register and what people can do. And this is especially true for, say, the Tectonic console, where our users are going to be DevOps people and network administrators and things like this, and they probably don't want Google or anyone else handling their users, and they might not even want their cluster to be able to talk to anything outside of their firewall. So it's super important that they own the identity and that there's some user management API around things. Next is language and platform independence. And we at CoreOS, for the most part, we write a lot of Go, but Quay, also part of the CoreOS family, they're a Python shop, and we want to make sure that people in different platforms and different applications can all talk to the same identity provider, and you're not being tied to a specific, instead of language bindings, we want it to be API based or something that's separate from your web app that'll handle authentication for you. And open source is super important for us too. Most of our projects are open source, and if we're going to be putting stuff like this, if we're going to be putting this in our products, we can't have it be based on some other commercial solution. And if we're going to try to get upstream support and things like Kubernetes, then we need to have some sort of open source solution. And of course, security is paramount in authentication and identity providing solution. So it turns out there's a standard upon which we can build all this, which helps us meet all these requirements, and that is OpenID Connect, or OIDC. So the first thing to know is if you're thinking, oh, OpenID Connect, it must have something to do with OpenID. It really doesn't. So it bears no resemblance to the OpenID or even relationship, really, except that it comes from the same foundation. It's much more, put your minds more in the OAuth 2 world when you're thinking about OpenID Connect. In fact, it is based on, OpenID Connect builds upon OAuth 2 and is a non-strict superset of OAuth 2. So they take a lot of things that OAuth 2 leaves unspecified and concretizes it and makes it part of the standard. And that's what my colleague Walden there calls typed OAuth 2. And I'll get into a little more details about what that means later on. It's widely adopted. It's the third-party single sign-on solution for Google. Facebook uses it, Amazon, lots of other people. And as such, there's lots of client libraries in every language under the sun that is still in use. So that's good. So in case you're new to OAuth 2 or just need a refresher, I'm just going to go over real quick what the basic OAuth 2 flow is. If you're super into OAuth 2 and you're noticing that I'm leaving off the resource server part of it, that's intentional because it doesn't really fit into the simple use case here and the common use case of just logging someone into your web app. So first, a note about the terminology here. Your web app in OAuth 2 world is called the client, which confuses people because people think of the person at a browser as the client. But your web app is the client, your identity provider is the authorization server, and the human is the resource owner, or usually human. It could be a command line or something too. But we'll deal with the human case right now. So the first thing that happens is, as you've seen a million times, is the user requests a protected page at the client end. The client then redirects the user to the authorization server because it doesn't recognize them. There's no cookie or just there's no way of identifying them. The user then goes to the authorization server and authenticates, typically with email address or password. The user is given an authorization grant, which is just an opaque string. It has no structure or meaning. It's just a bunch of random bytes that the authorization server is keeping track of. And then the user takes that, presents it to the client. This is all done by a redirect, of course. The user's not actually manually doing these things. It's lots of redirecting behind the scenes. And then the client, behind the scenes, talks directly to the authorization server and exchanges that grant for an access token. And that access token, again, is an opaque bunch of bytes. And so far, so good. And then what do you do now? So typically what you want is like, OK, now who is this person? Can I get an email address? Can I get some sort of unique identifier? Can I get their name? Can I get anything about them? And this is kind of where OAuth 2 really kind of is like, well, that's not specified, right? And it tends to be different for every OAuth 2 provider. So it's different for Google, it's different for GitHub, it's a little different for everyone who's doing OAuth. And consequently, the clients all have to have kind of hard-coded logic on like, well, for Google, this is how you get the email and blah, blah, blah. All that OAuth 2 specifies is, well, now you have this access token, you can do stuff on the user's behalf at some API somewhere, right? So, and everyone kind of handles that differently. So OpenID Connect. Let's talk about what the difference is there. So first thing is a matter of terminology. They take client and they call that relying party, which is, I think, a little bit clearer. They take Authorization server becomes the identity provider, and resource owner, sanely, becomes end user. So same things, just different names. And now let's look at the flow. For the most part, everything's the same, or it seems to be. There's a few different, there's some terminology differences, but everything seems to be the same. However, there's something very important happening out of band of all this, and that is periodically, your relying parties, your clients, are syncing to the identity provider at a well-known endpoint on the server, and because the server is publishing public keys, which it uses to sign things with. And so now the relying party has these keys, and you notice that instead of client exchanges .z code for opaque token, it says an ID token, a JWT. And what that is something with structure. It's not just an opaque string. It is, first of all, it is signed, meaning you can verify that it came from where it says it's coming from, your identity provider, and it has some structure to it. It has information about the user. And that's really good in two ways, because first of all, like I said, it's another layer of security where OAuth 2 is completely reliant on TLS infrastructure for security. Here we have this other signing thing, which is useful. And the second thing is that now there is a standard bunch of claims in the JWT that give you information about the user. So it's always the same for all OpenID clients. There's a standard bunch of claims. They're in a standard format. You know where to look for them. And it saves you going an extra hop to the identity provider to get that email address. So that's super useful too. It saves another network request, right? So Jose, how does it do all this signing and claims and all this stuff? So there's the other spec, which is super important, that OpenID Connect builds on, besides OAuth 2, is Jose, which is the JavaScript object signing and encryption standard. And the first thing it presents to you is this JWK, which is a JavaScript web key. And that's just a JSON data structure that represents a cryptographic key. It has a field in a JSON structure where it says what kind of algorithm you're using, and then it has another bunch of fields depending on what kind of algorithm you're using, which describe the key. So there'll be a public key stuck in there somewhere. Then there's this thing called JWS, which is JavaScript web signing, right? Signature. And that is exactly what it shows there. It's this Jose header, which is this JWK and some other stuff maybe. Your arbitrary bytes of payload, so it could be anything, base64 encoded, and a dot in between each one of these things. And then finally, at the end, a signature of the first two things together, right? So building on the JWS and JWK, finally we get to the JWT, which is a signed JWS with a JSON payload. It's not just arbitrary bytes, and now we've got a JSON payload, and it contains claims, which is information about the user. And you're always going to get these claims right here: subject, issuer, audience, and expires. So it's saying these things will be held true until it expires, until this token expires, and it's typically a short expiry time, like 5 minutes or so. The subject is who the user is. The issuer is your unique identifier, which is the URL of your issuer, your DEX installation or your OpenID installation. And audience is your client. So basically, and so these things together will say this person is signed into this account. They can do things. These claims are true for this user, for this issuer, for this client, right? And so you can verify the signature and everything and make sure that those things are valid for your client. And then in addition, there's other claims that are standard. It provides like email, which is email address, email verified, and that is whether or not the identity provider providing these claims has done the due diligence to say that this is email address really belongs to this person. And in Google's case, it's easy because they have Gmail. So if you've signed in to your Gmail account, you can be reasonably sure that that person really owns that account. That's not always true because sometimes identity providers are not so coupled to their to the emails that people have, name, birth date, address, things like this. And then there's non-standard claims too. So you can kind of put in arbitrary things there that are useful for your situation. And if you're going to be having some big interop with lots of different clients, and you expect this to be used by useful beyond your own world, you should register these things with the OpenID Foundation. But otherwise, you can sort of, as long as you namespace them and don't conflict with things, you can use them for your own sort of devious purposes. And we use them for things like email verification and password resetting. We put a claim in a password reset token to make sure that the password that the person is resetting or the hash of it at least, matches the password that they're trying to, their existing password, so that you can't do something like take an attacker, if they got an old password resetting link, they couldn't, change your password or something. And these things last for a very short amount of time. So it's stuff like that. So JWT, it's a super useful spec, used for a lot of different things. If you're going to use OIDC, if you're going to use JWTs, please read this, or I can. I know you probably don't want to copy it all down, but somehow I'll make this available. But just note that there are some really easy mistakes to make when you're verifying a JavaScript web token. The most notable is that because the algorithm is provided in the JWT itself, you can set it to none and then present it to a client to verify. And none is a valid algorithm in the JWK land. And it'll just say, okay, none, it's verified, everything's good, and you can do things on people's behalf. So you have to be sure that in production, that's just meant for development, that you're actually verifying that the algorithm you're verifying is the algorithm that the identity provider has actually published, and it matches, and that's very important. But these vulnerabilities have been out for a little bit of time, and most of the clients out there have been updated to make sure that they're handling this stuff properly. But be careful, because security is important. So finally, we get to DEX, and this is just a little diagram here showing how we're using DEX right now in production on Tectonic.com. There's a Tectonic customer right there. They can either log in with name and password, email address and password directly on Tectonic.com's DEX installation, or we could delegate to Google for authentication. And behind the scenes, we have a stack of DEX workers, one DEX overlord, and a Postgres instance. So the DEX workers they handle all the heavy lifting. That's your front-end web servers there that are stateless and horizontally scale. Postgres handles all state, and the overlord handles things like key rotation and stuff. So a key concept in DEX is connectors. Like you saw back there, and I mentioned, you can log in either via Google or using local authentication. So connectors, which are completely configurable by the deployer, are what delegates authentication. It says how people can authenticate. And this is what lets users choose how they want to log in. So the two connectors that DEX currently ships with is a local connector, email address and password, and an OIDC connector, which lets you delegate authority or authentication to yet another OIDC provider. So DEX is itself an OIDC identity provider, but in this case, it acts as a relying party or client of another IDP. And this is just a little thing showing that because DEX is itself an OIDC provider, you can chain an arbitrary amount of them together, each one asking the other one to authenticate until the stack unwinds and comes back down. I don't have a good use case for this. It's just neat that you can do it if you wanted to. But someone will think of one day. Some of the other things, nice features that DEX provides is automatic key rotation. So even if your private key, which is doing the signatures, signing the JWTs is compromised, attackers are going to have to figure out how to mount a good attack before the keys get rotated. And hopefully at that point you'll have figured out that they're onto you or something. And in general, we're building with security in mind first and foremost. We have our private keys, are encrypted at rest, as are registered client secrets, so that clients, web apps clients are client ID and secrets cannot be compromised very easily. And it's also possible to rotate the symmetric encryption key that is used to encrypt all these things. We have scalable architecture, this one overlord, which is just doing sort of bookkeeping stuff, very lightweight, and you can, the workers are all essentially stateless and can be scaled out horizontally as much as possible. And we have a user management API, which is an API for managing users. And it's especially useful in situations where you don't want an open registration. Like Tectonic.com, anyone can register and sign up for an account and everything. But if this is your corporation's identity solution, you probably want to have a little bit tighter control over that. We don't have a UI for that yet, but we're working on that. But the API there exists, so these things can be built, or you can do command line stuff right now. The future, more connectors. We have folks in the community right now working on an LDAP connector, which is awesome, and that's going to be really good for your enterprise-y sort of installations. Better support for the user management API, UI, hopefully, and building some stuff into our command line client. Other storage backends. Postgres, not everyone wants to deal with Postgres. If you're a super small installation, maybe etcd is an easier solution for you if you have just a few users, or someone on the list wants Mongo. So those are possibilities. Two-factor login with Google Authenticator would be awesome, and that's definitely on the plans. And right now, once you choose if you want to be a local user or a Google user, you're kind of locked into that choice. But it would be nice if if a single user could have multiple remote identities and can log into any one of those and not have to just stay with the one they first logged in. So this whole notion of merging these remote identities is something that's coming down the line. Other than that, it's really up to what everyone wants and the needs of the community, what we need and what y'all need. So please participate if you're interested. And that's it. Thank you. And if I have a couple more minutes for questions here, if anyone wants to have any questions. Yes?
What happens if the overlord goes down?
Nothing. The overlord, basically the keys won't get rotated. But other than that, you'll be fine for a while until your keys expire. So yeah, it's just, yeah, exactly. Maybe there'll be some cruft accumulating in the database or something, but nothing bad will happen. You can still use everything. Yes?
So you mentioned systems like Shibboleth. Why invent another one?
That's a good question. There are systems that exist like Shibboleth. Why invent another one? Shibboleth is great, and I don't have a ton of experience with it, but it is not easy to deploy, and it's a very big system, and it's just kind of it's a little bit difficult to administer and manage, and I don't think it really I wasn't around for when we made the decision not to use Shibboleth, but that's my understanding. It can be a bear to get up and running, and we wanted something a little easier. This is a fairly easy system to deploy. Yep. Well, everything's got to start somewhere. Yeah. Yes?
So if I have a web app that uses OAuth 2 today, what would I have to change? What would I have to change to use DEX instead?
Right. To use DEX instead, you can, well, if you can find, depending on what language you're in, if you can find an existing OIDC client, then you should just use that if it's a vetted one, one that's well tested. Otherwise, you can use your existing OAuth 2 client. Then you'd have to just do a few other things. You'd have to sync to the key source, make sure you're downloading your keys, and then figure out, and then follow the JWT spec to unpack your JWT and verify a signature. And it uses all standard cryptographic algorithms that are pretty easily available. It's in most languages, and it's JSON, so it's fairly easy to, unpack this stuff on base64 encode it, verify signature, and that's pretty much it. Cool. Yes.
So you said you were going to support the two-factor through Google. Are you going to support the U2F standard?
I don't know. Sure. Yeah. Like
That's the standard for two-factor or
Yeah.
multi-factor.
Yeah. I haven't delved into the two-factor bits yet, but if there's a standard, we're definitely more on board with standards than proprietary solutions. So yeah, that seems to make sense if that's the standard. Yeah. Cool. All right. Thank you guys very much.